Edmond Haley, a world-renowned astronomer, mathematician and physicist, successful in his work in cosmology and remembered for predicting the orbit of a comet, Halley's Comet. But did you know that Halley was actually very close with another incredibly famous physicist? Not only from their time, but of all time? Sir Isaac Newton, a fellow physicist known for developing the theory of gravity and for penning the laws of motion, suitably named Newton's laws, was a close colleague and friend of Halley's, with their support for one another being of profound importance for their individual achievements. In this video, I will specifically be talking about how Halley assisted Newton in his works, with a particular focus upon the writing and publication of Newton's most famous piece, Philosophiae Naturalis Principia Mathematica, first published in 1687, that laid out the three laws of motion, in addition to many other things that we now consider to be fundamental facts in modern science. Before we discuss this, we should first discuss Halley's early life, education, and most importantly, how he came to meet Newton. Halley was born on the 8th of November 1656 in Haggerston, Shoreditch, East London. He was brought up in a wealthy family, with his father being a successful and wealthy property owner and soap maker. He was one of 3 children. For the majority of his childhood, Halley was homeschooled and tutored privately until he began attending St. Paul's School, an independent, predominantly day school near the Thames in London. Halley's talent for mathematics and astronomy was apparent by this stage, with him developing an early interest in the subjects that persisted into his adult life. Halley's flair for maths was known long before this point, however, but was only truly acknowledged once he began attending St. Paul's. In 1671, Halley was appointed the captain of the school, a role that perfectly reflected his potential and talents as a person. Halley's legacy has lived on at the school ever since his attendance and success, with one of the school's extracurricular societies, the Halley Research Community, being named in his memory. At the age of 17 in 1673, Halley began attending the University of Oxford, specifically the Queen's College, where he unsurprisingly studied astronomy. His family were very supportive of his academia, with them funding all of his educational pursuits and purchasing him some of the best astrological equipment, namely a 24-foot telescope that was available to them at the time. With that being said, in 1672, at the age of 15, Halley's mother passed away. As such, for the majority of the time, Halley's father was the primary provider for his son, being the one who purchased the astrological equipment for him. Halley never ended up completing his degree at Oxford, with him favouring the idea of exploring the world, which he committed to at the rear end of 1676. Despite this, he still gained much valuable experience and, most importantly, made many valuable connections to like-minded people, such as John Flamsteed, whom he was introduced to by letter at some time in 1675 when Halley supposedly wrote to him to correct some work. Flamsteed was an astronomer royal who studied at Jesus College at the University of Cambridge as an undergraduate student. Flamsteed had previously written a catalogue of all the stars he had observed in the Northern Hemisphere whilst working at the Royal Greenwich Observatory, which inspired Halley to do the same in the Southern Hemisphere. Following the resignation of his studies, Halley's newfound inspiration and his father's generous funding led to him setting off on a 3-month-long voyage for St. Helena, a British overseas territory in the southern Atlantic, where he set up an observatory and took note of and observed 341 stars, within which he found a cluster. Additionally, he devised a method by which one could observe the movements of Venus across the disk of the Sun. He did this by also finding the transmission of Mercury, which he realised would be similar to that of Venus. Using this, he planned to find the size of the solar system. Had it not been for his father's useful connections to some highly influential people, someone as influential as King Charles II, who was in fact very scientifically orientated as a ruler, Halley's voyage would never have been possible, as the king provided him with connections to the East India Company, who brought Halley with them on their next sail to St. Helena. The findings from this voyage were what led to the writing of his first publication, 1678's Star Catalogue, which was the first of its kind and made for quite the revelation in the field. It was the first publication of its nature by which the locations of each star was noted. This publication was what really made Halley known amongst his peers, so much so that he was elected a Fellow of the Royal Society at the age of just 22, making him one of the youngest Fellows of all time. As part of his new position, he worked alongside the aforementioned John Flamsteed. Furthermore, King Charles II was so in awe of Halley and his work that he insisted that Oxford University award Halley the master's degree that he had previously been working towards, even though he did not complete the course. In 1680, Halley headed out on yet another voyage, this time to the west and southwest of Europe, with his old school friend Robert Nelson. During his time in France, specifically the western city of Calais, Halley observed a bright comet which he found rather curious, and which he would later see again when in Paris. Halley was keen to determine the orbit of the comet, and so, alongside Giovanni Cassini, did just that. Skipping a few years to 1682, Halley continued his observations of what would later be referred to as Halley's Comet, and also got married to a woman called Mary Tuke, the daughter of a successful auditor. The couple settled in the London borough of Islington and went on to have 3 children together, a son named Edmund and 2 daughters named Margaret and Catherine. In the same year, 1682, Halley met a man with whom he would develop one of the most important relationships in scientific history, a relationship by which gravitational forces and the laws of motion become common knowledge. That is right, he met Sir Isaac Newton, a lonely academic and alumni of the University of Cambridge, who has since become one of the most famous scientists in history. The pair would not meet again until 1684, the same year in which Halley's father was brutally murdered, an event which was tragic. Halley approached Newton alongside 2 other Royal Society Fellows, Sir Christopher Wren and Robert Hooke, with a relatively simple question about the development of a theory and mechanical explanation for planetary motion, with which progress had been rather slow. Newton showed the others his calculations for the project, which he solved, and shared with them his theory that it was an eclipse that kept the Earth in its orbit with the Sun. Newton, however, lacked proof due to misplacing part of his calculations. But in spite of this, Halley was impressed, so much so that he asked Newton to expand his field of study and allow him to prove the work for him. These calculations and the corresponding theory were the basis for the proof of gravitational forces. This is how Halley became involved with Newton's vital work. The 4 of these scientists all had a desire to be the first to make an extraordinary revelation in this field, and so the sense of competition was strong indeed. Perhaps this may explain why Halley was so keen to assist Newton in his research. Still, Halley's encouragement was just what Newton needed, and, as was asked of him, he expanded his scope of study and started over with his calculations. Halley provided Newton with money, motivation, and advice where needed, and eventually this accumulated in him proofreading and bringing the world-famous Philosophiae Naturalis Principia Mathematica, in English, the mathematical principles of natural philosophy, or shortened simply to Principia, to print in 1687. This succeeded a supposed manuscript that had apparently been sent by Newton to Halley in 1684, following his visit, titled De Moto Corporum Ingerum, which roughly translates to On the Motion of Bodies in an Orbit. Halley was suitably credited on Principia, and it was this that he would later base his own highly successful research paper on, using Newton's discovery as proof for his own theory. Following the publication of Principia in 1687, Halley achieved many great things in his own career. He continued working with the Royal Society, being an editor of the journal Philosophical Transactions since 1685, a post that he continued to hold until 1693. Via this post, Halley was able to publish the second part of his observations from his past voyage to St. Helena. Fast forward a few years, and Halley was appointed Savilian Professor of Geometry at the University of Oxford, a position that he held with great pride following rejection by the university in 1691, when he applied to be the civilian chair of astronomy. The reason for his rejection? His religious views. Being an atheist never proved to be much of an issue for Halley, even in a hyper-religious society of 17th century Britain. Only on this one occasion did this prove to be a problem. It was the year after his landing of this post that was truly fundamental for Halley, being the year that he published his groundbreaking synopsis Astronomae Cometicae, in which he proposed that comets, like planets, move around the Sun in an elliptical orbit, and will thus return periodically. Using Newton's laws of gravitational forces, Halley described the parabolic orbits of 24 comets that had previously been seen between 1337 and 1698, using both primary and secondary sources, trying to debunk the theory that comets only appear once. Halley said that the gravitational interactions between comets and planets would impact on the return of the comet. As such, he was able to compare the characteristics of several comets between the period, the characteristics of which were so similar that they must have been successive returns of the same comet. From this, he predicted the return of the comet, what would soon be called Halley's Comet, in 1758. For all of his work, Halley was awarded an honorary doctorate of laws from the University of Oxford in 1710. Halley was never knighted, something that many scientists believe was very much deserved of him, especially when considering that Isaac Newton was. Halley continued his work long into his elderly years, and in 1716 he devised a method by which the distance of the Earth from the Sun could be figured out. In addition, he proposed two types of diving bells that could be used for underwater exploration. Later, he compared the position of stars according to data that was recorded by Greek philosopher Ptolemy, and from this was able to deduce the motion of stars. He predicted the motion of 4 stars and had a 50-50 success rate. Another 2 years later, and Halley took over the position that had long been held by an old colleague of his, John Flamsteed, following his passing earlier that year. The name of the position? Astronomer Royal. Halley held this position until his eventual death on the 14th of January 1742 at the age of 85, far exceeding the average life expectancy of the period. He left behind his 2 daughters and wife, the latter of which died 5 years after him. Halley passed away in Greenwich, London, and was eventually buried alongside his wife in St. Margaret's Church in Westminster, near his observatory. As you can likely infer, Halley did not survive to see his comet pass by Earth on Christmas Day, passing away 16 years too early. Halley's predictions were proven to be correct, and so he was honoured by the comet suitably being named after him. This naming has been consistent, and people continue to refer to that particular comet as Halley's Comet. Halley's legacy has, as such, persisted, and his work continues to act as a fundamental part of astronomy. Whilst people may know Halley for this, fewer people will know of his input in Principia, which is absolutely worthy of note given how vital this publication was to physics and science on the whole. This is why I chose to refer to him as a sidekick of science. I'd like to thank you for watching this video. I do hope that you found it interesting and or enjoyable, and if you did, then I kindly ask you to leave a like and comment and share your thoughts, as this will be much appreciated. Thanks again for your time, and remember to always remain inquisitive. Halley continued his work long into his elderly years, and in 1716 he devised a method by which the distance of the Earth from the Sun could be figured out.